Welcome back to another episode of Hands-on SAP Devs. We've been continuing to explore the HANA Open SAP HANA 7 course and updating it for use in the latest version of SAP HANA Cloud and updating it for the Cloud Application Programming Model and doing it all in the SAP Business Application Studio as well. This week we continue the series, although we're nearing the end. We want to continue with the project, and a couple things that I did in between episodes here. I don't think it has a real material impact, but well, for one, I had to renew my my HANA, not my HANA Cloud, my SAP Cloud Platform trial. So I had to reset everything up, reclone my project from Git and recreate my my HDI containers. But that took a few minutes, no big deal really. But while I was in there updating my project, there was a new version of the SAP CDS module, so CAP, just came out last week. So I did go ahead update to that latest version, and while I was in here, I made a couple of other version updates, like the 2.6 version of the HANA client came out. The rest were really minor releases, and I did, of course, I reran my npm install, pulled down the latest versions, and I did a little retesting. Like I said, I didn't see any material differences or any major changes that would impact anything that we've done so far in the project. But I wanted to point that out in case anybody is following along at home. And maybe I do bump into a new feature or something a little bit later in the video series to let you know I had done that update. But otherwise, we want to continue along. If you remember from the last couple episodes, we had adjusted and added our own custom bootstrap to the Cloud Application Programming Model service handler. And in that custom bootstrap, we had not only extended support, so that not only do we have OData v4, but we also have OData v2, and we've got pure REST handlers as well. And we added some third-party modules in as well, like our Swagger UI for testing. But we also began to see where we could code our own handler endpoints. And, we did some of those to demonstrate some things that we could do with the HANA client directly. Up to this point, though, we haven't done anything really amazing with those custom handler endpoints. I mean, yes, we added some nice utilities into our service, but in today's episode, I want to begin showing you some things that are truly unique. They're good reasons why you might want to break out of the Cloud Application Programming Model. So we're going to look at either using unique features of HANA or returning a body type in the response that you would not get with OData. For instance, maybe a file download type that's formatted as Excel or zip. And we're going to look at using WebSockets within our service as well. And all these are really outside the scope of what you do with OData and outside the possibility of what you could currently model as a service interface with Cloud Application Programming Model. But we're going to integrate it into the same service once again, so you have all the functionality there side by side. We can see how we can, for our application, we've actually modeled and built almost all the functionality using the Cloud Application Programming Model. But for a few of those breakout areas where we need to go outside what it can do, that's no problem. We can do that, and we can fully integrate it into our existing service. All right, let's start today by creating another handler in our service. And this one is going to do some Excel processing. So let's just call it excel.js. And I have the code prepared over here, so let me bring it in, and then we'll have a look at it in detail. Going to create two endpoints here. And I actually don't know if I need Yeah, that's okay. So that's just if I want to test it directly. But we're going to create one endpoint that is going to test an Excel download. And we're going to use just a third-party Node.js module that will produce true Excel output format. We'll just hand it JSON data. So what you can see here is we're going to connect to the HANA database. We're going to send it a query, select top 10 purchase orders, their products, gross amounts, and then when we execute that query, we'll get it back as JSON, and we'll pass that JSON into the Excel module, tell it to build us a tab named purchase orders and put that data in it. And then we'll process that as a file download and send it back in the response. Likewise, we're going to do an Excel upload. Now, this is a little bit more complicated because now we have to take data in via an upload. Certainly a little bit more complicated than downloading, where we simply have to put it into the response but set a certain header to say that it is a file download. In a file upload, we're going to use a body parser because we're going to get a multi-part upload here. And this body parser will put it all back together for us. So we don't have to deal with processing a multi-part body. We just have to tell it, yeah, it's an application octet string, and it will reassemble that into a raw stream. And when we do the upload, we use this body parser as a middleware. We're basically telling Express when anything comes into this URL, then use this middleware to process it. So that will take the body, automatically put it into the format we need, and put it and reformat the request body object that we see here. We can use the Excel the same Excel module here that we use to create the output. We can use to process input as well. We're telling it to parse that raw body, and then we're just going to console log it out for now. And I'm going to upload a small Excel spreadsheet just so we can see it working, which we should see it come back in the response as it will give us JSON data back, and then we'll just stringify it. You should see that Excel data converted to JSON format. Okay, so all we have to do is add that file. Remember, we have the dynamic processing logic here in our bootstrap that's going to look for any files in the routes folder and automatically load those into our service. So all we had to do is create the excel.js file in the routes folder, and we're good to go. Let's go ahead and do a npm start to restart our CAP service. And there, that is started up. And we can go ahead and do a quick test just to make sure I haven't broken anything in the meantime. Yeah, our OData v4 service still works. That looks good. Let's just test real quick and make sure our OData v2 is still working. Yes, that's working as well. So that all looks good. We can go to our custom endpoint, like our status. Yep, that still looks good. But for testing this, rather than test it from the browser directly, particularly since we need the file upload functionality, this is where our Swagger UI will come in very handy again. And you notice now, in addition to the exercises, which we created last week, we had the JS doc for the Excel download and upload. So the Swagger UI documentation block is being used here as well. And we've even, the Swagger UI is really cool. We can do things like tell it, hey, I want to expect a request body, and it's going to be an Excel file of octet stream, and it's going to be a binary string upload. And the Swagger UI will take care of that for us. But first, let's check out the download. It knows that we're expecting a Excel type, and if we just go ahead and execute this, then we can see the headers, what we got back. If we do the download file, that will process the actual download. Let's go here. this a couple times. Past testing. But when we open the Excel file, I'm just going to open on my other monitor. So we'll just give it a second for Excel to open up here, and then I'll drag it over to the monitor where I'm recording. There we go. And what we see, purchase order tab, purchase orders tab, and here's our data, purchase order ID, product ID, and amount, which is exactly what we selected here in our query. And that's what we got in our Excel output, and not a text tab delimited or comma separated values, but a true XLSX format. So now let's try the upload one. And notice this is a post operation now instead of a get operation. So we're going to send data back to the server instead of request data from the server. So we can go ahead and say try out, which it should ask us for a file. This is one of the great things about the Swagger UI for testing, is it makes it so easy to test some of the more complicated actions like post, like file attachments and complex bodies and things like that. Why don't we just send it back the same Excel file that we just got? So we'll just choose that and we'll say execute. That will upload it to the server. And there's our request body coming back. We see all data imported, and then we see a JSON representation of that body. But that wasn't what was uploaded. It was the XLSX content that was uploaded. We then parsed it using the same Excel module, and it turned it back into JSON for us. So this can be a great way to bring data back into your system, upload data, configuration, all kinds of things, and your own application level logic. We only outputted it here to the log and to the response, but most times you would then take that data and insert it into a table or do some validation with it or something like that. But we've seen how we can now add these types of different response bodies, complex request objects, processing of file attachments. These are all advanced features, but things we often need when we're building business applications and can go right along with our standard OData services. All right, now let's look at similar processing here for zip download. Same concept, that we want obviously a different body type, and we want to use a third-party module to help us create the output. In this case, a node zip module. The first example, we're going to create a custom zip and create a folder file structure within that zip, and then send that down as a file attachment. We're just going to hard code the content of this particular zip file. And the second one, this is probably the more realistic example. Once again, I'm going to do a HANA database query to read a set of data, and then I'm going to take that in JSON format. And actually, I'm going to turn this into text tab delimited. I could have combined it together with the Excel, I guess, but I wanted to give you an example here where the zip adds additional value. So we're going to take a large amount of text data as text tab delimited. We're going to zip that up, and then we're going to send that down as a file attachment as well. And I've already, like I said, I already added that here in the system. Let's restart our service. There we are. And we'll refresh our Swagger UI. And now we have a zip option as well. Let's look at the manually created zip file first. So we'll just try this out. Execute. Once again, we get our download file. And let's just, we'll put it here. I've done this a couple of times. This is why we got the number on the end. But there we are. There's our folder that we created. There's our little text file that's within that folder. Oh, wow. That opened on both my monitors at the same time. But this is the new zip processing in Node.js. There we are. It's a really large notepad window. And then we have our demo 2. This is also the new zip processing node. There we are. So we can see how we can create content in files and folders within the zip output. And let's look at our database query one now as well. We'll just say execute, download the file. We'll go ahead and just stick that here as well. I've done this multiple times. And there you are, the work list. And there's a single po.text. And once again, wow, really big window. Doesn't seem to want to maximize in the window that I want it in. There we are. And there's our text tab delimited data out of the zip file, but obviously compressed within the zip file. You can see that uncompressed, it would be not huge, but 135 kilobytes. But then zip compressed, it's 16 kilobytes. So, we saved a little bit of space. You can imagine if there was a lot more data, that would be a significant savings, particularly when downloading the file. And for the last part of today's episode, let's look at a WebSockets example. Now, I put a lot of this in place in advance, so let's walk through it. First of all, what we want to do is we want to build a little chat server. And we want multiple clients to be able to connect to the server and issue a message, and then their chat message be pushed to all the listeners. So we need to be able to send data from the client to the server using WebSockets, and then the server needs to communicate out to multiple clients to redistribute out that message. So this is a simple to understand, but good example of what you can do with WebSockets. The idea that you can push data from the server to multiple clients that are listening. There's no polling involved. There's no need for every client to constantly communicate with the server. When there's something that the client is interested in or has registered to listen for, then the server will notify it. So a more efficient way of pushing data to the client side. Now, what we've done is we've just added another route handler to our service, this chatserver.js. And if you remember all the way back in the bootstrap, when we added this last week, when we added the custom routes, when we actually start up each file in this routes folder, is we pass it the app, which is Express, but we also pass it the HTTP server, the low-level HTTP server that was initialized by the Cloud Application Programming Model. And we were able to get that here when we do a CDS server to start up the CDS initialization. We can get back that HTTP server, and then we can pass it into our route handlers as well. We're going to need that HTTP server because we're not just going to work with Express here. We're actually going to go a lower level than Express and attach directly to the HTTP server because we're going to listen with a completely different protocol using WebSockets. Now, we haven't used that HTTP server in any of our other handlers. If we look at them, like if we go back to our Excel, we just accept the app, the Express handler. And that works just fine. In JavaScript, you can pass more parameters than what the receiver accepts. Everything's kind of like assumed to be an optional parameter in that case, right? So we just simply ignore the HTTP server in most of our handlers. But when we come here to the chat server, we're going to accept both Express and we're going to accept the low-level server as well. And what we've done here is we're using WS. There's a couple different WebSocket implementations that are available for Node.js. This is the one that I've used for years. A simple WebSocket implementation works quite well. But what I'm able to do here is just create an instance of a WebSocket server. And then what happens, the WebSocket server class, and then I create a new instance of a WebSocket server. telling it that I don't actually want it to create a full server because I'm going to attach it to the existing HTTP server, and what path it should listen on. And then we take the full HTTP server that was initialized by the Cloud Application Programming Model, and that all of our Cloud Application Programming Model is running within, and we attach a new event to it saying when you get an upgrade request, I want to process that. That's what we're saying here. And when we get the upgrade request, and you can have multiple handlers listening to the upgrade request, but we're registering that we want some code here to be processed on the upgrade request. I'm going to look at the URL. And if the URL is /rest chat server, then I'm going to go ahead and handle this and say, yes, I want to handle the upgrade, and I want to connect my WebSocket to the server for this instance. What this allows us to do is we're only attaching our instance of a WebSocket server if this is the incoming path. It allows us to attach different WebSocket servers to different paths, and it makes sure that we don't disrupt anything in the larger Cloud Application Programming Model service either, in case sometime down the road maybe it would start to implement WebSockets as well. We don't want to disrupt anything it's doing, so we'll only attach to the server for requests that come in via this path name. From that point forward, we're able to, well, first of all, I create a little reusable function here that I call broadcast, and it basically just says for all clients that are attached to this WebSocket server, when we get data in, I want to send that data back out to all clients. So that's all that we're doing here. And here I'm saying on connect, when a new client connects to the WebSocket server, I want to send a message back out and broadcast that as well. So we're able to say hello from Node.js server. And this is an event handler here to say when I receive a message from that client, this is the logic that I want to process. And every client that connects is going to get the same message handler. And what we want to do when we receive a message from a particular client, we're basically just going to broadcast that out to all other clients. So there's lots of different things you could do here with WebSockets. We could have just client-to-client communication, where we say a specific client. In this case, this is going to be a public chat room. So any client connected to it, when they broadcast something, when they send a message, we're going to broadcast that back out to all other connected clients. Okay? And that's all we need here. What do we have? 50 lines of code. Not even that, really, with all the spacing and formatting. And we've created an entire chat server. Now, the only thing is, in order to test this, is we're going to need a user interface now. So what I've done is we have an app router that I've already initialized here. You know, I've set up an XS app JSON so we can proxy our backend service calls through it. And up to this point, it really hasn't had anything in it. But I have gone ahead and I've added this index HTML. And all this does is add an SAP U shell, basically a Fiori Launchpad shell that we can use for testing. And we can embed our UI5 or Fiori apps inside here. And already I've added like the Swagger UI and the system monitoring, even our OData v4 endpoint. I've added all of that into this little test UI. But the main thing that I want that is of interest here is I've added an SAP UI5 component, this exercise chat. And it's here in a separate folder, exercise chat. I don't want to go into all the SAP UI5 specifics here, but basically I'm creating a very simple SAP UI5 Freestyle application. Let's see if we can do this. Open with Layout Editor. And there you see we're going to have a pretty simple UI where each user is going to have a username. And we're just going to put a value in there. We're not actually pulling the user ID or anything. This is just a little test application. Then we're going to have a chat log that's going to show us our chat history. And we're going to have an input field where we can type a new chat message and press send to send that message to the server. So user interface isn't all that spectacular or fancy. Even if we look at it in the XML format, pretty basic stuff, right? We're creating a little JSON model. We're not even connecting to an OData service or anything like that. Just doing a local JSON model for the user and the chat and the message log, all on the client side. All the server-side logic is here in the controller. And not a whole lot here. Basically, when we initialize the controller, then we want to attach to the WebSocket server. And actually, let me back up here. I think in the index HTML, or in our component JS, this is where we do initialize the chat model. We fill a couple of names. Yeah, nothing too terribly interesting there. So going back to our controller, this is where most of the interesting logic is that we want to attach, and we're using the built-in WebSocket functionality of SAP UI5, and it gives us the ability to, that's where this connection object is. You see here we're basically saying a new WebSocket. This is the client-side WebSocket class that is part of SAP UI5. We're giving it the path that it should process on, the same as our server path is expecting. And we're able to say things like connect, attach message. So we basically registering that we want to listen to messages. When there are errors coming off across the WebSocket, then we're just going to pop those up with... and the same thing, if we close the socket, we're going to pop up that message. And this is the interesting thing. This is the send message function. This is what's called by the UI. When we press the button, send message, this is the implementation of it. Basically, we want to get the data out of the OData model. We want to turn it into JSON, and then we're going to send it to the server. And that's all that we're doing. So let's go ahead and start this up. We'll start here. Yeah. So we'll do an npm start to start our CAP service. And I'm going to go ahead and open another terminal window here. And in this one, I'm going to run my app router, also locally, just within the shell here of the Business Application Studio. I'm not having to deploy anything to Cloud Foundry or Kima. I'm just all running this locally here. So I'll do an npm start in the app router, and it's going to start up here on port 5000. And that's the one I want to go ahead and open in another tab. And now if we go here, we can see like our Swagger UI still opens. It's being served by our CAP service, but now it's running in place inside our shell. So everything should still work just fine in place here. Yep, see, still get my hello world node.js. Go back here to my, go back home to my shell. Our system monitoring with our Express status monitor, that's still good as well. I had that open in a separate tab instead of open in place in the shell. Same thing here. Oh, my URL is wrong because we added OData before in there. So that's okay. I need to adjust the URL that I'm linking to there. This is all working here as well. If we look at the OS information, that's from last week's episode. So that's all working. But what we're interested in is the WebSocket chat, right? So we open it in a new tab, and we are connected to the server. Hello from Node.js server. We can actually see that in our log, that a WebSocket has become connected. And let's take this and let's open this in a new tab. Bear with me here as I size my windows around. There we are. Where'd my other one go? There we are. Let's open another one. Student 6, student 5. Let's go ahead. Let's go crazy here. Let's do a third one. There, that's student 1. And now would see, let's get rid of that. We got multiple sockets connected. It's a little bit bigger. So I'm going to read that. And now student number 6 is going to say hi. Oh, my WebSocket connection closed. Why did my WebSocket connection close? Well, that's interesting. Let's try refreshing. Let's try this again. Let's say hi and send the message, and it worked right. Student 3 said hi, and it got broadcast. It sees it itself, and actually is getting broadcast back to it from the server, like echoing it back. And student 2 also received the message. When student 2 chats, then it gets the message as well. And our little third window that I forgot about, yeah, even though it had that WebSocket error, or connection closed, I'm not sure why. Student 1, it's still working here on this one. There we are. And this one broadcasts out to all the others as well. And all this logic, it's not because I'm running them on the same client either. Somebody else could connect to this URL over the internet, and they would be getting all the messages as well. They're all going back to the server. When anyone presses that button, it sends that particular message back to the server, and then the server broadcasts it out to all listening clients. And once again, I hope you've enjoyed this episode. We've gone quite a bit deeper into the service handlers and some of the more advanced features of why you might want to create your own service handler and go beyond what you can do with OData services in the cloud application programming model. I think particularly the WebSockets example is very powerful and quite interesting in doing something that goes well beyond just OData services. With that, we also dipped our toes into the user interface just a little bit, and that's where we're going to pick up next week. We're going to continue with more user interface examples, and we're going to focus on how we can add Fiori annotations to our cloud application programming model and use those to generate both OData v2 and OData v4 based Fiori UIs. I didn't really show you much about the UI in this example. It was a freestyle UI, and I was really focused on the WebSockets. Next episode, we'll go much more into how those annotations allow us to generate user interfaces.